Before I start, so who here is using Elixir? Be it for personal projects or in production or just play with it a little bit? Okay, great. Awesome. So this talk is about Elixir. It's kind of like trying to give an overview where Elixir is right now and the directions we want to go in the future. Okay? So what I'll try to do is try to include a little bit of what is happening with Elixir, even from the most basic features to the most advanced ones, and discuss about it. Okay? So a year ago, okay, we were releasing Elixir 1.0. They were actually happened in September 2014, and it was really, really exciting. And one of the most exciting things that we had happening was that by the time Elixir 1.0 came out, we had more than 180 contributors. So 180 different developers, they contributed to the language, and that's just code, right? We're not talking about all the other contributors, like people organizing meetups, telling about Elixir to their work and so on. So it was really fantastic. And by the time Elixir 1.0 came out, we already had 3 books announced by 3 major publishing companies. And we also already had our first Elixir conference that happened in Austin in July last year. And what is really exciting about this is that one of the goals for Elixir as a programming language is that we want Elixir to be extensible. I like to say that computer science today is such a wide field, right? That it's impossible for us to have a programming language that is going to work across all those fields really, really well. So one of the language design goals was that the language is extensible, so we can take it to other domains and extend it and bring it, make it productive in all the different kind of domains we're working on. And that's exactly what we saw happening. So one of the things that we hear a lot is folks using Elixir for the web infrastructure. So anything from running on the TCP socket or UDP socket like protocol, and then you need to build something using binary parsing, and it's going to be great at that. But also developers building web applications, API backends, onto distributed systems. Okay, there is one very exciting talk we had at Erlang. The video is already online. You can check later at Erlang San Francisco, Erlang Packers San Francisco this year, about folks using Elixir for building distributed game platform, which is really cool. And we also had Elixir conference happening a week ago, and we had a bunch of great talks about folks using Elixir to build embedded systems. So you can get Elixir payments and everything into 20 megabytes, put into an embedded system, and bring that thing live. So there's folks are actually building embedded hardware software that ships with Elixir, and they're selling that. So a bunch of interesting stuff happening in that area. We also hear folks using Elixir in financial video platforms, for example, on areas that are supposed to be very data intensive, so they have data coming all the time, and they're using Elixir to process data. And also on the Windows blocks for people building graphical user interfaces with Elixir. So this is really rewarding. Okay, and that's kind of what happened and what we saw happening in the last year. And if you want to hear a little bit more about those use cases, my company, Platform Tech, we did a series very obviously named called Companies Using Elixir Introduction, where you can find some of the use cases and people talking about that. And it's great if you want to share with your friends or coworkers if you want to try to use Elixir. Okay, so cool. So that's what was happening for this last time, the last year. And right now, we're no longer, however, in Elixir 1.0. We are with Elixir 1.1. It was released kind of 10 days ago. And Elixir 1.1, so it was released last month. Okay, and it's really exciting to say that from the last year up to now, Elixir 1.1, we gained more than 100 contributors, right? So when Elixir 1.0 came out, we had kind of 180 contributors, and now in Elixir 1.1, there are almost 300 contributors that have contributed to the language, language altogether. So thanks for everyone that is helping with code and making the language continue to grow and move forward. The community is also growing really, really fast. So we just reached 1,000 packages on XPM, and we have more than 6 million downloads altogether. Okay. And what I want to do for this talk is to talk a little bit about what is exactly Elixir 1.1 and what we can expect as developers. Okay. So the best source to know what we have in Elixir 1.1 is, if you're not familiar yet, you can go to the Elixir website, have the news there, or you can go to our changelog, and that kind of lists everything that happened from this 1 year to get Elixir 1.1. It's very well detailed, okay? And as you can expect, with Elixir being a functional programming language, we have a lot more functions, right? So this is almost all the functions that we added. Don't worry about the names here, right? And just to give an idea of what we added to Elixir 1.1, it's almost all functions. I had to remove 2 because the names were too big and they were messing my layout, so they're out. But they're almost all here, okay? And just to give an idea of what we can expect. So for example, one of the modules that we use in Elixir a lot is the enum module, right? That we use to work with collections, lists, and so on. And it got a bunch of convenience functions. So for example, can you read the back, see what is here? Or what is it? Okay. Yeah, so I'll go slow and try to be really more detailed. So we got a bunch of functions in the enum module. So one of those new functions is the enum dedupe. So we had enum unique that you would give a list and it would return a list with only the unique items, removing the duplicates. And what dedupe does is that it removes the duplicates only if they appear in a row. So here I have a list with 1, 1, 2, 2, 1, 1, and it's going to return 1, 2, and 1. We now finally have a function to take a random item from a collection. So here it's saying enum random passing a range, and it's going to return me a random number, or take even like 3 random elements from the collection. Okay, so just very small functions that are convenient. And when you need them, you're going to find them based on the library now. Another improvement that we have to Elixir are new functions to the string module. And this one is really cool. It's jar distance, and this function can be used to calculate the distance between 2 strings. And we use this, for example, in Mix now. So if you're using Mix, which is our build tool, and you by accident type like Mix hello, and you meant to type Mix help, now you're going to say, hey, I can see that you're trying to run this thing called hello, but it doesn't really exist. Did you mean help instead? Maybe that's what I meant. So we are going to use this function a lot more in Elixir to help you exactly when typos happen. You can use that for variables, so like, right? You write your code, and then you do a typo in the variable name, then you say, hey, you typed this variable, maybe you want this one instead. So it's a very handy function that we expect to use more and more. And some other nice features that we got from Elixir when they came to the task module. So the task module, it already exists in Elixir 0.0, the old Elixir version. And one of the things you can do with it is the async await pattern. Okay? So who here is familiar with the async await pattern in Elixir? We use task async await. Cool. So what is task async await? So as we know in Elixir, all the code, it runs inside processes, right? So we have our code, everything is happening inside processes. And sometimes, for example, a very simple use case, we kind of want to execute some task, execute something particular at the same time. So imagine that you're building a web application and you need to access 3 different APIs at the same time to get information. Let's say, so for example, I heard a case of people building, they are like a sport application where you can go and visit your soccer team, and every time access with that page, you need to go to Twitter to get the latest things that they were publishing to Twitter. You need to go to their Flickr page. So what you can do when you have tasks in Elixir is that there is a web request, and you say, oh, now I want to create a task. Okay, that's the async await pattern. I want to create a task that's going to concurrently access a Twitter. And then you create another task that is going to access Flickr. And then you create another task that's going to access something else. And they are all running at the same time. And then when you are ready to get the results back, you call await. That's why it's the async await pattern. You're running something on the side, and then when you did whatever you wanted to do, meanwhile you call await, and they're going to wait until you have a response back. So here what we're doing is that, for example, just an example, I'm saying task.async, and that's creating a task, okay, that is executing the code that you give to the task, making the function. And then at some point when you want to know the result, you're going to call await, and you're going to give it a timeout, which is the time you want to wait for that thing to finish. And this is how it works with Elixir. The issue with this is that task await, it's kind of, it's very binary. Or it's going to give the result, or you're going to wait the timeout, which in this case 5 seconds, and then it's going to exit, it's going to error with a timeout. Okay? But sometimes you don't want that. Sometimes you want to say, hey, did you by any chance finish? Right? And then depending if the task finished or not, we do something else. So that's exactly what we added to Elixir 1.1. So here at the top, what I'm doing is that we have now something, instead of calling a wait, we can say task.view. And that's a way for her to say, hey, instead of waiting and then erroring if something doesn't happen, we can say, I want to wait 5 seconds. And then if it works, good, you give me the result. And then if it doesn't work, just let me know, and then I can choose what I want to do next. So what we can do now is that we can do things like, hey, did you finish by any chance? And then you wait a little bit, then, oh, I didn't finish. And then you can try to wait a little bit more. And then at some point you say, okay, I waited enough. I don't want to wait anymore. Then you can split the shutdown. So now, working with tasks in Elixir 1.1 is getting nicer and nicer because we're adding a couple more continuous functions. Okay? And those are some of the functions that we added to Elixir. As I showed, the list is quite comprehensive. But Elixir, when you install it, it's not only Elixir itself. It comes with some other things built in. And one of those things is Mix, which is the build tool, right? So when you are doing Elixir, one of the things that you end up eventually doing is using like mix new or mix init.new to create a new project. And that's all powered by Mix, our build tool. And Mix got a bunch of nice improvements. For example, now we have a mix profile.fprof task that you can use to profile your code. So for example, here I have an example calling like mix profile.fprof, and then you can give it a script. And that's going to go run that script and measure how much time it's being spent in each function, and so on. Okay, so you cannot see here, but what you're saying is that you're saying all the functions that were called, how many times each function was called, how much time it was spent on that function, including the things that that function in particular calls, because when you have a function, that function calls on the function, right? So this is going to include all the time, and this is going to include the time in that function specifically, not including the children. So this is great, right? So you want to see why things are not working as fast as we expect them to be. That task is going to help. And that's one of the nice improvements we got with Mix, but we got a bunch of other nice ones. So one of those is that now in Elixir 1.1, you're going to see faster compilation times. And that's because every time you compile your code with Elixir, what we did is that we kind of generated a graph. So if you have a file A and that file A called file B, we would track that. So every time you change B, you need to recompile A, right? Recompile A because we need to track what changes, and depending on what changes, we recompile. And with Elixir 0.0, we did not make a difference between runtime dependencies and compile time dependencies. Okay, which meant that if you changed something, it was very likely that it would propagate from the whole graph and you end up compile a bunch of stuff. Especially if you're using Phoenix, right? So in Phoenix, for example, you have the router, which is when you have a request, the router sends it to this controller, or to this controller, or to this controller. So the router kind of like access everything, but it's only at runtime. So what would happen in in old versions of Elixir is that if you change something in the router or something that the router depended on, it would cause your whole Phoenix process to recompile. But now with this feature we have in Elixir 1, you're going to get much faster compilation times because we're just trying the things that are important. Okay? So it's a really nice improvement, and having faster compilation times is always welcome. Some other things related to compilation in Elixir is that when you are inside the interactive Elixir, which is the Elixir terminal, the Elixir shell, a lot of people would change something in their project, and then they wanted to recompile their project, and there was no way. So they would go to the mailing list and say, hey, I just changed something in my project, and I want to reload my project from the terminal, and not need to close the terminal and start a new one. Now in Elixir 1 we have a small function called recompile that's going to recompile our project, and we had to add it because it was like almost every month there was someone sending me, hey, can we have that? So now we finally have that. And probably the first difference you're going to notice when you do Elixir 1 is that if you have a Git dependency in your project, right? So we have like hex packages, Git dependency and so on. We are now changing how the Git dependencies work to use HTTPS instead of Git, because HTTPS is faster and safer. And those are all features that old features that happen to the language. But as I said, the most important language features, they are often not related to code. And we saw a lot of exciting things happening in the community. So the first one was the addition of a code of conduct. So now we go to the Elixir story. We have a code of conduct there, and we added this to help guarantee a safe environment, a safe and open environment to everyone. So that was a very nice contribution from Slavia. And we also get a brand new documentation. So this is if you haven't checked it out, go to Elixir website, click on the docs, and you can see our new documentation have the most beautiful, clean, and readable documentation that I have ever seen, and that's for Elixir. And it's not for Elixir only. You can see that Phoenix and Echo and all other projects, they are already using this documentation, and you can use it in your projects too. You just need to add the documentation to your project as a dependency, and it's going to work. So, and I know from the Xbox they're doing some Lite work, and I know from them that they are working on even more features. So they're working, for example, on PDFs, like EPUB documents with documentation. If you can see here in the menu, we have also this section called Pages, which means that developers, they can now add guides and things like that to their projects. So this is really good because if you are building the guide to documentation, if you in your guide you say, for this code you're going to use module X, we are going to link the module with the documentation and so on, so you get cross-references on using it. Okay. And this is what we can expect with Elixir 1. It's already out. Just need to use whatever you installed Elixir to upgrade. But what I want to say for the rest of the talk is what we are working on and focusing for the next Elixir versions, okay? And the next one is going to be Elixir 1.2. And we don't want to wait, so we kind of waited a year for Elixir 1.1. And this time we don't want to wait a year again. And the main reason for that is because the main goal behind Elixir 1.2 is to migrate from Erlang 17 to Erlang 18. Okay? So if you're running Elixir 1.0 or Elixir 1.1, that version supports both Erlang 17 and Erlang 18 before. Okay? But with Elixir 1.2, we want to support only Erlang 18 plus. Okay? And the reason for that is because Erlang 18 has a bunch of great features that we want to leverage. So what is doing Erlang 18 that we are really excited about? So what is in Erlang 18 that we are really excited about? So one of the things that comes today, so in Elixir we have that thing called math, right? When you use percentage and curly brackets, and you put two things, that's a map. And today, if we try to create a map where the key is a variable, the compiler is going to right? The compiler is going to say, hey, that doesn't work. So now that finally works with Erlang 18. And even more important, with Erlang 18, we have official support for large maps.
Hello.
Okay. So just to recap, in Erlang 18 we now have variables in maps as a key. So you can now, if you have a variable and you want to use that as a key, that's going to work. And we have official support for large maps, and I'm going to expand on that, okay? So we have, in Elixir we have the maps data structure, and today it can only handle like a couple dozens of keys efficiently. If we put more and more keys, it starts getting slower, okay, in the old Erlang versions. So let's see what this means, okay? So if you're using Elixir 1.1 or 1.0, it's actually quite confusing because when you want to use a dictionary, which is something, a key value data structure, we end up having a bunch of options, right? So we have the keyword, which is a list of tuples. We have maps, right, which, as I said, is in the old versions, right, in Erlang 17, they are used only for holding a couple dozen of keys. And then if you want to store like hundreds, thousands, or millions of keys, you need to use #dict. And this is very confusing, especially for people that are starting. Sometimes people, they would, for example, they would post to the mailing list saying, hey, I had this code in Ruby or in Go, and then I rewrote it and it would take like 3 seconds, 5 seconds in those languages, and then they would rewrite it to Elixir, and it would take a minute. And they'll say, what is happening? And that's because they picked the wrong dictionary. Exactly because there are too many options. It's really, really confusing. And to kind of help and make things worse at the same time, we provide another module, which is the Dict module, to kind of unify all the APIs. So it's way too many options, and it's definitely confusing. But now in Elixir 1.2, because we're going to target Erlang 18 only, we have a much better plan here. We are going to have just 2 modules, okay? We are going to have just keyword lists, which is the thing we usually use as options, right? And they have some particular properties. And we're going to have maps. And maps is usually the one you're going to use if you want to perform pattern matching and so on. And now maps, they're going to be fast and scalable, right? So if you want to put 5 keys, it's going to be fine. If you want to put a million, it's going to be fine as well. And then we can, now you just have 2 options and you don't need to worry about all that kind of stuff, okay? So what is happening then is that with Elixir, we have those modules called Dict and Sat. And in Elixir 1.2, there is, so it's important, it's just Elixir 1.2, don't change your code yet, okay? It's coming soon. So with Elixir 1.2, #dict will be self-deprecated. And self-deprecated means you're just going to write the documentation, don't use this, you're going to remove it from the guides and so on. So #dict will be self-deprecated. You can now just use map. We also have a #set, which is similar to the #dict, but it's a set that will also be self-deprecated. You can now use the map set, which is a new data structure that's going to actually be faster than the #set too. And the Dict and Set modules, which are kind of the unified API, they will be self-deprecated too. Okay, so those are very welcome additions that are going to simplify the language and make everything easier and faster for everyone. And those are some features that are coming like 2.2 because of Erlang, but we have some features of our own as well. So one of the new features is what we call multi-aliases. So who wrote code like this in Elixir, where you say, hey, I want to alias my app food, and then I want to alias my app bar, and then I want to alias my app path, right? You have a bunch of alias, one after the other. And with Elixir 1.2, you'll be able to say, you'll be able to write all of those as alias my app, and then you open curly brackets, and then you can specify all the things at once. So it's a very handy addition. And we see very similar ones in both Scala and Rust. They allow you to do the same kind of thing. And Elixir works not only with aliases, but it also works with imports. So if you're importing functions with different modules, you can use the same syntax and so on. And as I said, we don't want to wait a lot for this new release. So we hope it will be be released still this year. So a good deadline is December 2015, but we hope it will be even earlier, possibly November. And while this release doesn't come out, there is one thing you can do, which is to upgrade to Erlang 18. Okay, so if you're not running on Elixir 1 yet, and if you're not running on Erlang 18, it's a great time in while to upgrade. So, and then when Elixir 2 comes, you're going to be ready because they are not going to break the chain this line. And it's always also important to say that we have worked with the OTP team that maintains and works with Erlang for providing faster compilation times for everyone, both for Erlang files and for Elixir files. So just upgrading to Erlang 18 today, we should get faster compilation times. So in my machine, like things they are to 10 to 20% faster when compiling Erlang tasks and so on. So just the faster compilation times, it's already working. And it's actually also worth pointing out that although Elixir 1 made compilation faster and Elixir 2 made the compilation faster too, compilation in Elixir is not slow, right? We compile code actually quite fast, but if we can continue to make it faster, right, it's always working because if we can save like 20 seconds, 30 seconds per day for everyone in this room, right, it mounts up really quickly. Okay, cool. So that's what we can expect in Elixir 2, and it's coming soon. And what I want to do for the rest of the talk is to talk about Elixir 3 and what we can expect in seeing Elixir 3. And it's important to say that everything I said about Elixir 2 is kind of guaranteed, it's going to be there. But everything I say from now on, there is no guarantee whatsoever that's going to come out with Elixir 3. They come out in Elixir 2 or Elixir 3 or Elixir never, okay? So, but those are the areas we are exploring right now, and I would like to share a little bit with you. So, if you have seen any of my talks about Elixir, I always talk about collections, okay? And that's because in Elixir we have this idea of collections, and we can work with different collections. It doesn't really matter if they are lists, sets, or dictionary behind the scenes. So the code I have here is that I have a widget, okay, and that's a collection, and the widget is typed into a none filter where I'm picking only the widgets with the color red. Okay, so now I have a whole collection of widgets. And then I say, okay, I want the widgets, only the ones that have the color red. And then after I get the widgets with the color red, I want to map those widgets into a tuple, getting the widget title and the widget height. And then after I do the mapping, I want to get all those intermediate results, which is the widget title and the height, and put it into a map, into a key value data structure. Okay? So now I have like, I have the widgets and then I filter them and then I map them and I put everything into a map so I can access the map by the title and get the height. Okay? And when we talk about collections, the way it works in Elixir is that widgets here, okay, that we have at the beginning, it can really be anything. It can be a list, it can be a set, as long as it implements what we call the enumerable protocol. Okay, and that's why the none module in Elixir knows how to work with a bunch of different data structures, because all of them, like ranges as well, all of them implement the enumerable protocol. And we call the widgets, in some literature, we call them sources, right? So widgets is the source, and then we have a bunch of transformations, and the results goes to what we call the sink, which is at the end, and it implements another protocol called the collectible. So, and as I said, because this thing is built with protocols, for example, here I can replace the widgets by something like csv.parse, something that's going to parse the widgets from a CSV file. And then instead of putting the results into a map, I can put the results, I can bring the results to my terminal. Okay, so this is the same code as before. I just changed the widgets to CSV parse so the data can come from a CSV file, and the results, instead of going to a map, it's going to something that prints the results to a terminal. But the issue with this code is that we say that everything here, everything is eager. So what's going to happen here is that first we are going to parse the CSV file and load the whole CSV file into memory. And then we're going to filter the whole CSV file and get only the widgets that have the color red. Okay, so now we have a huge list, and now we have a slightly new list, but smaller one. Okay, and then we map creating another list, and then we write everything to the terminal. So what means here is that if you have a very big CSV file like this, 100 millions of entries, I don't know why anybody would do that, but as an example, if you had a very big CSV file, if you executed this code, the code would start to run, and then you would wait some time until everything is processing, and then at the end, just at the end, you would see everything created at once, okay? Because everything is eager, right? And then we are generating a bunch of intermediate lists throughout the process. But in Elixir, and this is the Elixir version today, right? We have this, since Elixir 1.0, we have this idea of laziness. So here I'm calling the num module. If I replace the num module by the stream module, okay, it has exactly the same functions. It has filter and map, but now everything is lazy. And being lazy means that instead of parsing the CSV file, right, and then filtering everything, and then mapping everything and so on, when we have laziness, instead of parsing the whole file, we are going to parse the first entry, and then we check if we want to continue processing that entry, if the color is red, and then we map getting the title and the height, and then we print. And then we start with the next entry in the CSV file. So instead of doing everything eager, right, everything at once eagerly, we do things lazily. So we have like each entry is going through the stream, and then after the first entry is done, we get the second entry and then the third entry. And what it means in this case is that instead of waiting some time and get all the results printed in the terminal at the end, you're going to see the results being printed at the terminal as they come, right? You're going to see them coming one by one, okay? And this is already an Elixir, and it's really, really handy. And the way it works, that when you're using streams, we don't perform the computation, we just store the computation. And when you call stream run at the end, that was the only thing I added, okay? It kind of merges all the computations into one, and then we execute the thing, okay? And that's how it works today, and we have been here for a while. But once we designed this and we added this to the language, there was a very distinct question, which is the split. If I am storing all the computation and I know how I want to process my data, so I have data in one hand and I have the computation in the other hand, we can actually do interesting things like, what if I get this computation and split it into different Elixir processes, okay? So now I can process the data in parallel for free, okay? Because this is exactly what it does. It puts the data and the computation apart, and that gives us a lot of flexibility of doing things in whatever way we want. And we have been exploring that. So we started collections, and then we added laziness, and then we were saying, what if we can add something like parallelism, and then we call pipeline parallelism. So this is the same code as before, okay? We only added a new function call here, right after CSV parse, which is string.async. And what string.async is going to do is that it's going to get everything that happened before and say, hey, I want to execute that in a separate process. So now we have the same code as before. What is happening is that when we are parsing the CSV file, we are doing that in another process. So we have this process that's now only going to parse the CSV file, and as soon as it parses the first entry, it's going to send a message to the next process that's going to filter, map, and print to the terminal. Okay, so now everything was happening on a single process, and by adding this very small function call called string.async, we started to have a little bit more of parallelism. What could happen is that if we have like this pipeline of operations, okay, when we add multiple calls to string.async, 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 every time you call it, you're going to create a new process where the data that is going to perform operations on the data, and the data is going to pass through. It's going to look something like this. Okay, so here I have the CSV parsing process. It's going, as soon as it gets the first item, it's going to send to another process that can filter it, then it sends to another process that can map it, and it sends to another process that can print it, and so on. Okay? And that's pipeline parallelism. Okay? So we started looking at this, right? Exactly at this theme. So now we have like this kind of topology where we have those processes and the data is specified. And when we started to think about those things, each of those stages here, each of those those circles, each one of those is going to be a process. And one of the things that we always ask when we create a process in Elixir, right? We need to ask the question, what's going to happen if one of those processes crash, right? So if we wrote that, right? Imagine that we have data going through and this process in the middle crashes. We need to think how we're going to react. Should we break the whole pipeline? Should we break only the process that are upstream because we can assume that the change happened somewhere up here? So we need to ask this question, right? So, well, what's going to happen if one of those processes crash? And we also need to ask, how can we provide back pressure? Because imagine that one stage in the middle, right? You have many processes, the data is going by, and imagine that one stage in the middle is slower than other. If you're just sending messages, that process is going to get more and more messages, and it's going to start to get slow, and your system is going to run out of memory because you have data coming in from all other places, and it's going to just accumulate everything in that process. So we actually need a way to provide that pressure. We actually need a way for the whole pipeline to say, imagine that, for example, the data is coming from, you are processing financial system data, right? So the data is coming to the system, you need to handle that, okay? Or you're using like Apache Kafka or RabbitMQ that are logging systems. You don't want the data to come all the time. You want to be able to say, hey, stop sending data because I cannot process it as fast as you're sending it to me. And so when we look at that, those are the kind of questions that start to pop up, okay? And another way to ask those questions is if we want each stage here to be a process, and we want to handle failure, we now need to think about supervision, okay? So how are we going to we have like this topology of data going through those processes. How are we going to supervise those processes so we can react to failures? And we use supervision in Elixir for that, okay? So the question is how to make streams, which is the thing that we started, the stream map, the stream filter, and so on, how we can make streams supervised processes. And if we look at the topology that we have defined here, right? If we look at this topology, it's not even really smart because what is happening here is that we have one stage doing one computation, the other stage doing another computation, the other stage doing another computation, and we are sending the data through those stages, and that's not cheap. Usually we don't want to be sending the data around, right? Because that's kind of that's not cheap, it's expensive. We don't want to be sending the data around. We actually want to have other ways of doing parallelism. Because every time you send the data between processes, the data is copied, okay? We don't want to do that. So we were looking at this. We were looking at this topology, okay, for a very long time and trying to say, how can we solve those problems? And it was really hard. We were stuck on this issue for a long period of time because we're saying, how we can go from list streams to supervised processes. And about 2 or 3 months ago, we had a great breakthrough in this issue because instead of asking how to make streams supervised processes, we decided to ask how to make supervised processes stream data. And it's a very similar question, but it's different, right? Because one, we are saying, oh, let's start through streams and go to processes. This one is like, hey, we have processes. Let's start with the processes. And just later on, you're going to figure out how to map to that issue we have originally talked about, of how to map into collections. And the end result of this question, the answer that we came up with it, is what we are calling the gen router. Okay? So as we have gen server and Elixir supervisor and so on, we are exploring this new behavior called the gen router. And what the gen router does, it's 2 things that it's supposed to do, okay? So the gen router, it's going to connect sources to sinks, and the gen router, they are demand driven, okay? And we are going to explore those 2 things next. So here's how a gen router would work, okay? We have, so here we have the gen router, and then right here in the middle we have a process, which is the gen router itself. And then gen router has, and each of those circles, again, they are processes. So the gen router has processes here that we call them sources. So we have sources that are sending data to the router, okay? And then the router is based on the criteria that we, the developers, define, is going to send this data to what we call sinks. right? So here we have 4 sinks. So the data is coming to the router from the sources, and the router is sending data to the sink. And it's important to notice that, so here we have left, middle, and right. And it's important to notice that if we ignore the right part here, okay, if we keep only this left part, the gen router is the sink for the sources here, right? So all those processes here, they don't really care about the gen router. They just know that they are sending data to someone. And the process that you send data to, it's always called a sink. And similarly, if we ignore the left part, right, we can see that the gen router is a source for all those other processes, because all that those other processes care is that they are receiving data from somewhere, and you always receive data from the source. Okay, so that's what the gen router does. It connects sinks to sources. It's going to sources to sinks. It's going to receive data from sources, right, and send them to other processes that we call sinks, and they are all processes at the end of the day. So, and if the gen router is kind of a sink and source at the same time, because it's receiving data and sending data to some other parts, we can break the gen router in 2 parts. The in part that is responsible for handling incoming requests, incoming data, right? And the out part that is responsible for sending the data out. So here's how you would start a gen router, okay? You're going to, as with the server, agents, and tasks and things like that, you usually call start link. So gen router dot start link, and you pass 4 arguments. The first one is the name of the in part, which is how you're going to handle the incoming data, and some arguments for that. And the second one, and the third one is the name of the out part, which is how you're going to send the data that you receive, and the arguments for that. Okay? So one example here, what we could do is that one of the in part could be called single in, which means you're going to receive data from a single source. And the out part can be called broadcast out, which means that you're going to receive data and broadcast it to all the processes that are interested in that. Okay? So here's how it would look like. So single in, broadcast out router. So you have the data coming in from a single source, right? Then it reaches the router, and the router is going to send to all of the sinks that are receiving that data. So if you have, for example, one event coming in, that event is going to come to all of the sinks. Then you have another event coming, and then it goes to all of the sinks again, and so on. Okay? But this is really just one of the strategies that we can use with gen routers. So instead of single in, what we can do, we can do dynamic in. So the data can come from anywhere, right, into the router, and it's still, we can do dynamic in, broadcast out, so the data can come from anywhere, and we are broadcasting it again to all the processes. And this can be, so we can look at this and see, oh, I know what I can use this for. I can use this for an event system, right? So if you have, if your application you want to put data somewhere and allow anyone interested in that data to process it, like a logging system or an alarm system, and if you really want to do it in your application where you just send the data and whoever is interested can grab that, you can easily model that now with the gen router. You just need to give it the dynamic in part and the broadcast out part. But we can do other more interesting stuff. For example, now we have the dynamic in. Let's replace the broadcast out part by something called message queue out part. So now the difference here is that the data comes again dynamically from different sources, and instead of sending the data to all of the processes, okay, what we are going to do is that we are going to send the data to the less busy process. So instead of sending to everyone, so now I have one coming in, and at the beginning they're not those processes, they're not doing anything, right? So we have one coming in, and they say, oh, which process is the one less busy? The first one is the one less busy. So we're going to send data to that. And then there's another one. The one now is busy, right? Because it's processing that data. So let's send that to the second process. And then let's send that to the third process, fourth process, and so on. So what can we use this for? We can use this for like performing jobs, like load balancing. So a simple example, imagine that you wanted to send email in your application. And you don't want to send that email from the request that is serving the web request, right? So what you can do is that you can put this gen router, and then it's going to find the process that is less busy to send that email. And then the next request comes to send the next email, it's going to find the other one less busy, and so on. So with those short examples, you could already see some very interesting use cases, right, for the general author. So one can use for handling events. You want to send an event, and that event is going to be sent for everyone interested. But you can also use it as a way to load balance jobs, right, across a pool of processes. So it's very easy now if you want to perform something with a pool, like accessing APIs, processing data, sending emails, you'll be able to easily model that with the general author tree. And that's the first part of general author understand, right? It connects sources to sinks using different topologies. But the other part of general author is even more important, which is that general authors, they are demand driven, okay? So let's go back to a very simple topology, just so we can understand what we mean by demand driven. So here imagine that I have A, right? I have process A, which is sending data to B, which is sending data to C, okay? Just a very simple topology. And as we said, A is a source to B, and B is a sink to A, because A is sending data to B, and B is receiving that data. And at the same time, B is a source to C, and C is a sink to B. So what's going to happen here, because they are demand-driven, when we connect those processes together, A is not going to start sending data immediately, okay? What needs to happen first is that C first needs to ask for data, and that's why it is demand-driven. So before any data goes into the system, okay, C needs to say, hey, I'm asking for 10 items. It's going to ask B for 10 items. And now B is going to receive that request and say, oh, okay, I'm going then to ask A for 10 items. And now that A, for example, so here can be the interface to your database, to the queue system, okay? So A now knows, oh, now I know that my system can handle 10 items, so I'm going to ask the logging system, whatever is upstream, to send me 10 items. And then A is going to receive the items and send them downstream, okay? And that's why it's demand-driven. We don't flood our system with data. We always ask for data first, and then based on the demand that our system can handle, we start sending the data downstream. So this is really important because it's the back pressure mechanism. It's the guarantee that we're not going to flood our system with data, and then we're going to die a horrible slow death because we're running out of memory and everything because we just send more data than we can handle. Okay? So what demand-driven means? So it's a message contract. So what is happening is that those processes, they know how to send messages to each other, to ask data and send data, and it gives us back pressure, right? Because now, instead of, so if C was this slow process, we're not going to flood C. C can tell what is the boundary of our system, right? Why it's on, and how much data it can handle. And the general author that we're talking about is just one of the many ways you can do demand-driven stuff. And all of this is not really new. There is a bunch of old research, and we have seen a lot of things happening with orchestras that bring a lot of those ideas true. Okay, so I want to particularly thank Konrad from the Academy that he has answered a lot of my questions on how to implement all these demand-driven stuff. Okay, so here's one last example of how we can use this stuff to build infrastructure. So imagine that you want to build a TCP acceptor, okay, which is something that's going to accept requests, TCP requests, and activate. After we add this to Elixir, it's going to be very easy, right? Because what we can do is that we're going to create a source, which is the TCP acceptor, which is the thing that's going to wait for connections. And then our sink is going to be a supervisor that is going to create a new process to handle every new TCP connection. And then so here we create the source as one line of code, we create the sink, which is a supervisor, it's another line of code, and then we just connect them. And now we are ready to receive TCP connections and handle them in our system in a supervised way. Don't worry about the details here, I will close this slide so you can see everything worked out today. So what we are really expecting for future versions of Elixir, right, is to define this demand-driven contract, because that's how we can apply back pressure to our Elixir systems, okay? And we're going to define the agent router and everything we talked about here. So the dynamic in, broadcast out, message queue out. So building like event system, load balancing jobs is going to be easier than ever. That's it. And just at the end, we're going to figure out how we can integrate all of that with streams. So that's it. That's what I have to share about what Elixir is right now and what we expect to happen in the future. I wanted to once again thank my company, Tech, for investing on all on Elixir and the community and on the work happening behind this. And that's it. That was the talk about Elixir. Thank you very much.
Entonces, preguntas. First of all, thank you for creating Elixir. It's amazing. And my question is, what was going through your head when you made the decision to create a new programming language?
So yeah, it's a long story. I'll try to make it short. But what happened is that I was working on Ruby and Rails, and I was one of the people responsible for making it more efficient on their multi-core. And that was very frustrating work. It was really hard to, we always had issues popping out because we don't have Bluetooth and so on. And that's when I decided to look at other technologies. And one of the technologies that I really enjoyed and I was really amazed by was the Erlang virtual machine. And but at the same time, so the way I described that happening is that I liked everything I saw in the Erlang virtual machine, but I hated the things I didn't see. So I talked a little bit about protocols, which is one of the ways of doing polymorphism. And we have like papers about doing polymorphism in functional languages that are 3 decades old, and we don't have this mechanism in Erlang. And a little bit about the whole metaprogramming parts with macros. So I felt like, wait, this is really, really great, but I am really missing some of the things I am using it. I was also missing a very good tooling and so on. And that was basically the driver, one of the drivers actually, for creating Elixir. The other drivers was actually, I was already noticing the whole multi-core revolution was happening. We're starting to have more and more cores, and I wanted to explore my own ideas and see how these things would work out, and how it would work out, especially in the context of the Erlang virtual machines, and try to provide a new language for the Erlang virtual machine with some different characteristics than the one we have in Erlang itself. Thank you.
Hi, I quite interested about in how do you get an idea, just like the idea that Jen Router just mentioned, from conception to build. And as you mentioned, you made contact with the ACA team. Is there any other influence or any other source of ideas?
Yeah, great question. Thank you. So so I actually have a huge list of things that I want to explore in the future, and I think they could be improved. So and it's often a long process. So we have been thinking about this whole collection of things for, I would say, it's probably getting closer to 2 years. And what I learned when doing Elixir is that you cannot really rush ideas. You need to, sometimes you get stuck into a problem, and if it's a conceptual problem, sitting in front of the computer for 8 hours is not going to make you solve the conceptual problem really fast. So sometimes you just need to let it go, and also be really curious about what other communities are doing out there, and try to see if those ideas are interesting, if they can be ported and they can be implemented efficiently in the environment that we are currently working on. So there are definitely other ideas coming from other places, different from ACA.
and from other communities. So we got a little bit of everything. When you look at Elixir, right, it's a little bit of Python, it's a little bit of Haskell, which is how our Ruby system works. You can see a lot more from Clojure and a lot more from Ruby. So there's always different ideas coming from everywhere. And then sometimes we see something that is interesting, and then we look at it and say, okay, this is interesting and can potentially solve problems, but I don't know. And I don't know exactly if that's effectively going to solve problems, or it's actually going to be useful. Because one of the other things that we could do is that we could, for example, just get all ideas from everywhere, right? And then it becomes too bloated, it's too hard. We would have exactly the same issues that we had with dictionaries. Like, you want to solve a problem, then there are just way too many options, and that's actually confusing in the long term. It's like one of the most complaints that people have with Scala, for example, which is too big, right? And then teams end up using different parts of the language, and we definitely don't want that. So even if we see a good idea, we need to let it sink a little bit and think which problems we can solve this. So, for example, with General, we were thinking about this for a long while, because we were thinking about how we want to do data processing and have events flowing into the system, but at the same time, how it's going to map with everything that is in the language. So there are some things in Elixir that I'm not happy with. They are great, but I think it could be better. So for example, Geneva, I think it's okay, right? But it could be better, and with Genwalker, I think we're able to solve the problem with Geneva. So there is another issue that kind of annoys me with Elixir, which is we have the supervisor, and supervisor has different strategies. And one strategy in particular, which is the simple one for one, changes completely how the supervisor behaves. Right, so the functions return different results, and it's fine. I mean, Erlang has been doing that for a long period of time, and we can do that, and it's going to be fine. But it could be better. So sometimes we have like those issues on the side, things that could be better, ideas that we see elsewhere, and at some point it suddenly clicks, and we say, oh, I guess I can get this and this and this, and we are going to have a good abstraction that can solve some of the problems we have today, while also making it more accessible and bringing exciting features to the language that people can use in production and so on. So it's kind of a mix and grab and a lot of patience. Thank you.
Thank you to go to Mexico. It's good to have you here. And my question is, which process your team followed to test the Elixir line?
Okay, so what is the process for testing Elixir? Elixir has a really good and comprehensive test suite. So we mostly rely on the test suite itself, which is great because sometimes projects have test suite, but you don't have confidence in the test suite, right? Which is bad. But we do have a lot of confidence in our test suite, and we can also leverage the fact that some of the complex parts, like supervisors, they are actually provided by Erlang, so we just rely on them and their whole testing system. There are things and we also release the release candidates and beta versions before every new release, so everyone can try it out, and if there's something that our test suite didn't catch, they help us catch. But when we have integration servers, so the things we expect is that as good practices, they will be there. The only thing that could be better, honestly, is Windows support. So I know, for example, which helps. So I know the Erlang, the OTP team, they test like Erlang with all kinds of operating systems that you can expect. And we don't have such a comprehensive suite, which is not such a big problem because we're mostly generating bytecode. But for example, we don't do extensive testing for Windows. We don't have like a continuous integration server running in Windows in particular. And that's something that could be better, but in general, we just rely a lot on best practices, like very good coverage, integration server, and so on, to get the confidence we need for testing and releasing Elixir.
Thank you.
More questions? Yes.
Hi, so working on a startup primarily using Rails and Ruby, and so my question is, when do you expect that Elixir will be kind of the preferred choice for something like web development if you're looking to start a new startup. What are your thoughts? Like currently, how would you compare if you were to build kind of something, and your priority is, speed to market as well as, ability to hold on as technology improves, and how do you view it from the creator's perspective?
Okay, so when Elixir, so my company, we are still mostly Ruby on Rails consultancy, and we started with Elixir this year. And after Elixir 0 came out, so every time I do every year and a half, I do a presentation of what is going to be the things coming with Elixir. I do a presentation to them. What are the things that we expect in Elixir for the next 1 year or a half. And after Elixir 1.0 came out, right, I was like, okay, I'm done. Like, this is the name we expect it to be, and we're going to build on top. And that's one of the reasons why it took 1 year for Elixir 1.0, because I want exactly the community to settle. And all of my time, most of my time throughout that year was working on the ecosystem. So I was working with the team behind Phoenix. I worked on Acto, which is how you talk to the database, with Elixir, with the Acto team. I also worked with the documentation, so it was really a lot of effort in improving the ecosystem around. And one of the goals was exactly to put Elixir in a position where I could tell my company, like, hey, now if there's a new client and they are open to any technology, you're going to use Elixir and you're going to be just fine, right? You're going to have like almost everything you expect to find in other places. It's going to be there. So it's, if you consider that like we're going in levels, like first is the language foundation that was Elixir, and then it came, let's say, the framework foundation, which is getting Phoenix ready, right, with its new ideas and also the foundation expect. Now we are in the position where everyone can definitely jump in, because we can start building applications, we can start using Elixir, and sometimes you're not going to find something as complete as in Rails or in other communities. Let's say you want to do file upload. So just now we're seeing some folks actually tackling file uploads and having packages that make it easier, but we are at that point already where we're just getting there, and maybe there's something that doesn't do file upload right now, but you can do something for our application in particular, or just use one of the solutions that are getting started. And the same thing with authentication. So I would say that you're like, if you're considering it to be a very long marathon, we've done like 90%, and now is the part where everyone contributes, which makes everything much easier, right? Because someone here can solve the file upload problem, someone else can solve the authentication problem, and then we are going to see more and more packages popping out exactly to solve these issues, and we just be able to rely on them. So that's the part that's missing. You're very at the end, and then if you're okay with like, maybe that's not there, and you need to enroll one particular part of application yourself instead of using something that was already existing, you're completely ready and fine to go. That's cool.
Hello. Well, I don't want to sound like a spoiler, but what's the advantage of the sync implementation with another event system?
The sync implementation, what do you mean?
The proposal for Elixir.
And compare it with which other systems?
Any like RabbitMQ.
Okay, so it's important to say that right now it's the answer, the very direct answer right now is that those are different things at this moment. Maybe in the long term we'll start seeing parts where they are more similar, but here it's like, imagine that. So one of the sources here for the system could be exactly RabbitMQ, because this is how the data is going to flow inside the same machine, right? Inside the same Elixir process. I didn't know that. So this proposal is how the data is going to flow inside a single Elixir node. When you're using RabbitMQ, you have a bunch of different nodes talking to each other. So imagine that you have the data, you have a machine with 24 cores. okay? And all those 24 cores could be processing data. So you need a way to get data from RabbitMQ into that Elixir node and then spread that data across the 24 cores. And RabbitMQ and those things that are working externally, they're not going to help with that. And that's the first step here. It's like, I am inside Elixir and I want to send events around. Like, for example, our log system, it's a very good candidate for using JMalker because it just want to, like, anyone who's interested to know the events that are happening. So right now they are completely separate, right? So one is living in distributed land. I want to have different machines communicating, putting things in the queue. And here we're thinking only inside Elixir, right? And how you can leverage all the cores efficiently and how you can send Elixir data and Elixir events around.
Great, thank you.
You're welcome. Thank you.
That's it.